So, you have done long division before, and I hope you remember how to do long division. Yes, Juliana, that is exactly what long division is. And I'm going to try my best as we go over this to run you an example alongside. But before I do, let's just recap. Back when you were in, I really think they started in maybe 5th grade, maybe.
Yeah, that's when my brother got this.
Okay, and you have a problem that looks like this.
And then you do the quadratics in it.
Okay. Oh, yes, we will be.
Ooh.
Tell me what the first thing what is your mental note that goes through your head as far as what your first step is when you go to work this problem?
It's going to be decimal like that.
What do you ask yourself?
What goes into 12 and 5?
So think about explaining this to a 5th grader for the very first time who's never done long division before. You would tell them first.
Divide.
Well, yeah, divide it, but divide what?
12 by 5.
How many times
And 12
will this go into that?
2.
Without going over, right? So what's the answer? What's 2? And what do you do with that 2?
Put it on top.
Put it at the top, right? Now, okay, what do we do with it now?
It becomes 25.4. That's the end.
But I don't want you to focus so much on the answer as the process of getting there. You're explaining to this to a kid who has never, ever, ever in their life done long division.
Okay, well, you subtract
So what do you
10
do?
from 12.
Where is 10 coming from? What is 10?
5 times 2 equals 10.
Okay, that's what I wanted you to get at. Here, you multiply, yes? And you write it here.
Minus, and then that's going to
Okay.
be 2.
Does everybody remember doing this?
No.
Okay. You don't remember doing this, Shani?
I did mine another way.
Okay.
For real. It was a short way. Like, it was like short.
Okay, well, we gotta do long division. All right, so your 5th grader is sitting here and they go, okay, I multiplied it through, now what?
Subtract. It's going to be 2.
Subtract.
First. It's going to first be 2 on the side.
12 minus 10 is
2.
2.
And then bring down the 7.
Bring down the next term, right, or the next number.
And it's going to be 27. And then you're going to add.
Now that process starts to repeat, right? So if you get the 3 or 4 steps down, then it's just a repeat. So we start back over. 5 goes into what? 27. Now I'm looking down here. How many times?
5.
Now I put that up top. Same thing.
27 minus 10.
Multiply. And what? Subtract. What's 27 minus 25? 2. Now I've hit a point where 5 can't go into 2, right? No decimals, though. What is this called? The remainder. Okay? I'm fixing to apply this to polynomials, so I don't want any decimals. Does anybody remember what else you can do with a remainder besides, yes, Sam,
Besides what?
besides decimals?
It's going to make it a fraction.
Bring down to 0, right?
Absolutely. Make it a fraction. Do y'all remember that?
It's going to be 1/4.
Look, listen, guys, because you can't have the decimals with the polynomials. That's why.
But the average 5th grader wouldn't know what 5 divided by 2 was.
No, but they would know what 5/2 is because they did fractions in 4th grade.
That's true.
So here, if I say plus 5 over 2, and then I just have them write their answer as 25 and 5/2. Oh, 2/5, I'm sorry. Ah!
That's so embarrassing.
It's remainder, 2/5, remainder over, I don't know. Tony came in during lunch and he says, I'm going to do my impression of Miss McGee. Ah! Okay, so we write it as remainder over what sits on the outside of the little house, right? Okay, if you can do this, you can do what I'm fixing to show you. It's just
Way harder.
longer. No, it's not. It's just, okay.
Division, what?
Understand, let me show you one more little background thing. I can't believe I wrote that wrong like that. This problem because it's going to be given to you in a lot of ways. This problem could be written as 127 divided by 5 like that. It could be written as 127 divided by 5 like that. Okay? Or I could say in words, what is 127 divided by
That's not a problem.
5? Yes, but you're going to have polynomials in place. What I'm getting at is I want you to understand if it's written any of these ways, you know which one goes outside and which one goes inside. Okay?
Yeah.
All right. Are we good? All right. We're just going to jump in. Actually, I got one more thing to tell you. In long division, it is very important that you have what we call placeholders. Okay? Placeholders do exactly what it sounds like they do. They hold the place. Now, if you look, placeholders for any missing
So X.
exponent. Well, yes, it's going to have an X on it, but if you look, I start with a power of what? 5. From your highest power down, you must have every single power. Okay? So in other words, I've got 5, so what do I need? 4. Well, there's not a 4. So instead, I'm going to put plus 0x4. That's a placeholder. I've got a 3. Uh-oh. Do you see that I'm missing a power of 2?
Plus 0x2.
Minus 6x plus 3.
So it's a lot like, I like to think of it as
Thank you. Excuse me. Sorry. Say again.
Cards. How you have to
You gotta have what? Yes. So you must have everything. Yeah. Everything down from the top down. All right. Let's set it up and do it. If you, I'm sorry. If you're kind of OCD about your notebook and you want to have, like you don't want something to go from one page to the next, you need a good bit of room for this first problem. Okay? All right. In fact, I'm going to make my pen size a little bit smaller.
Oh, God.
Remember, f of x is just function notation. That's just like y. It doesn't matter. I want to divide 3x to the 4th minus 5x cubed plus 4x minus 6 by
I can barely see that.
x squared. You can't see that?
Can we turn off the light?
Yeah.
Yeah, the lights is bright.
Minus 3x plus 5. Yeah, I'll hit the lights. They're supposed to be coming to fix my projector so it shines brighter. So you don't have to cut all the lights out. Alright, I'll give you a second to catch it because I want you to be watching also and not so worried about writing down real fast. Alright, I'm going to do the same problem that we did when we started. It was 5 into what? 127?
Yes.
I'm going to keep that running on the next page so I can keep going back and referencing that so when we get confused as to what goes where.
Oh,
All right.
I need a Q2 line for that.
Oh, yeah, no. All right. When I set this up, tell me which polynomial goes on the outside. The first one or the second one? The second one, right?
You said go on the outside?
All right. It goes on the outside of the little house. The first one or the second one?
Second one.
The second one, right? All right. You will see because we're going to use this to factor eventually.
So if I put this into a calculator, would I be able to get the result?
No.
It's completely impossible.
You could put, well, it depends on the calculator that you have,
What
but
about this?
no.
Because I have X's on this.
You do have X's, but you would store a value for X, and it would give you if it like plugged those values in for X, then divided the two.
If you just put X alone.
All right. Under the little house, right? I'm going to put my other one. Now be very careful because I must include placeholders here if I need them.
So
3x
4
to the 4th.
minus 5x to the 3rd plus 0x
Good job.
to the 2nd plus 0x, plus 4x minus 6.
And I'm set up and ready to go. All right. Flip back over to that other example we started with.
God, dang, you don't know.
What was the first step that we did in this problem?
See how many times I go to-
How many times does 5 go into 12? And we write it up here, right? So now I'm going to look at my polynomial. Now here's the thing with polynomials.
They don't have the same.
We only look at the first term, okay? They don't, but watch. And I'm going to ask myself, how many times does x squared go into 3x to the 4th?
3x.
Yes. In other words, remember, what do I need to multiply x squared by to get 3x to the 4th?
Second, because 2 plus 2 equals 4.
Correct. I need, it goes in there 3x to the 2nd times. Do we all see that?
I really like this.
Okay, think about your paper as a column. Keep all your exponents together that go together. So up top, I'm going to write my 3x to the 2nd here.
Why is it so far? Oh, because you're going to have
This is my x squared column. This is going to be my x column. This is going to be my constant column, and so on. Okay, neatness will kill you here if you're not a neat person with your math.
color code.
All right, now, take it back to the other problem. And I really want you to see the connection here, that the steps are exactly the same.
And then we're going to put it over.
What do you do now? You multiply, right? You multiplied here.
Okay, so
So I'm going to come over to my polynomial.
3x to the 4th.
This-
3x to the 4th.
It's going to multiply to everything though, okay? So remember when we were doing that section on polynomial operations and I said this seems really elementary right now and easy for you when you're just distributing one thing through, but you're going to see where this ties in. I need to multiply 3x squared by everything out here, okay? Now y'all stay with me. 3x squared times x squared is,
3x to the 4th.
I'm going to go to the column with the 4 powers and put that
So
here.
Just basically
Distribute through. What is 3x squared times negative 3x? Yes. Y'all be confident. Y'all said that very hesitantly. Negative 9x to the 3rd. There's still one more term there I haven't taken the 3x squared to.
X to the 2nd.
And that's this last one. And you're right. It's plus 15x squared. Now, I want to take a second and break for just a second and make sure everybody's with me.
Yeah.
Okay, same exact steps that we did with regular long division, we're just doing it with polynomials now. You all with me? All right, flip back over to the other example. Doop. Multiply it, right? Now what do we do?
Subtract
Subtract. Now here's where you're going to have to be careful.
the signs.
Absolutely, Juliana, you're absolutely right. I'm going to subtract this, but I am subtracting all of this. So remember when we did practice on subtracting polynomials? And we talked about how that subtraction sign changes the sign of everything in that parentheses afterwards?
So plus 9x to the 3rd minus.
No.
If you mess up, this is where it's going to happen, I guarantee you. Same, change, 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 change.
Why are we doing that?
Because we're subtracting that whole polynomial. We have to subtract everything. We can't just subtract the first term. We have to subtract all the terms. Now, if you've done it correctly, your first term should cancel out every single time. Does it?
Yep.
Yep.
I think.
Wait, no, since you're adding it.
Adding a negative to a
Oh,
positive.
that's true.
All right. Negative 5x cubed plus 9x cubed. 4x x cubed. 0x squared minus 15x squared.
Negative 15.
Negative 15 is.
X squared.
Okay. Now wait.
What about 4x?
We're fixing to, but I want you to see step by step, okay? Is everybody with me?
Yes.
I multiplied through, I subtracted, and that's where I am now. So flip back over to the other example. What do I do now?
Brings down to 27.
Bring down the next piece, right?
Then you're going to bring down 4x.
And I start repeating the process. So here, you're absolutely right. I'm going to bring down the 4x. Now, same process begins to repeat itself. Instead of saying, how many times does x go into 3x to the 4th, I'm going to say, how many times does x squared go into 4x cubed?
Why is it 4? Oh, because it's the beginning of
4x.
4x. That's correct. It goes in the x column. Yes.
Yes.
What do you multiply this by to get the first term here?
Then you multiply.
And then you multiply. 4x times x squared is what?
4x to the third.
4x times negative 3x and 4x times 5. Yes. Now what?
You're gonna
Somebody said it.
subtract and then the same change.
Subtract.
Same change. Right?
Yes. So I'm changing everything here. First terms cancel? Yes? Yes?
Yes.
Yes. Negative 15x squared plus 12x squared.
Negative 3x squared.
4x minus 20x.
Negative 16x.
Am I done?
Nope. Bring down the
Nope. I got another term to bring down. Should I make you want to be done real bad, don't you? We're not done yet. Bring down the 6.
Negative 3x would be going into the
Wow, you are on this, Juliana. All right. What do you multiply x squared by to get negative 3x squared?
negative 3.
Multiply around. Whose head's in the way? Tanner's?
My bad.
Negative 3. Make sure you're multiplying by a negative 3 because that's what I put up there. Negative 3 times x squared is...
Negative 3x squared.
And negative 3 times negative 3x is
9x.
9x. And negative 3 times 5 is
Negative 15.
absolutely. And then I do. I've used all my colors, I think.
That's plus
Same, change, 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 change. First ones cancel as they should.
Yeah.
Negative 16, negative 9.
25.
Negative 6 and 15.
Minus. Plus 5.
No, that's 9.
Yes? Now, everybody always says, wait, Miss McGee, how do I know when to stop?
You don't have no more
You have
things.
nothing.
1, I don't have anything else to pull down, but 2, can you multiply x squared by something to get negative 25x? No, right? Because x squared is bigger than negative 25x. So I stop, but I'm not quite done because I have to deal with this remainder. So flip back over to that same example.
You're gonna have to make it.
This was 5, multiply around 25. Here my remainder was 2. And we said all we have to do is go plus the remainder over
You're gonna have to bring bring,
Did I get some pressure?
are you gonna have to bring negative 25x plus 9 over
Shami.
x squared minus 3x?
Yes, yes. So all we do is we write plus, we take our remainder, which is negative 25x plus 9, divided by what sits on the outside here. X squared minus 3x plus 5. All that work for that. So if someone said, what is 3x to the 4th minus 5x cubed plus 4x minus 6 divided by x squared minus 3x plus 5, you would say, oh, I know that. It's 3x squared plus 4x minus 3 plus negative 25x plus 9 over x squared minus 3x plus 5.
I like it.
Good.
Anybody would ask me.
Sure they do. They ask me all the time. Walking down the road, I'll be walking through Walmart and say, hey, this is the game.
How much is 965 minus 12x plus 60?
All right, tell me what you think. Other than it being super long, tell me difficulty-wise. I'm seeing some thumbs up. I'm seeing some yes.
So that made a difference
It's gonna
because
be
of my
easy.
stuff.
There is a lot of room for careless mistake.
You better have a lot of
So this
questions.
took us around 15 minutes.
Okay, but remember, I'm explaining as we go. So I want to work one with you now, start to finish, so that you see whenever we're not going through explaining step by step by step by step. I'm going to give you several tries.
Several.
Then it's not.
I feel like it still take like 15 minutes.
It really doesn't. I promise you, it does not. It doesn't. It's very intimidating when you look at it. It's a lot of work, but none of the work is that difficult. It
What
is.
did you do at 15?
It's a lot of Algebra 1 concepts pulled together to do an Algebra 2 concept. All right, let's do another one.
This is all of them gonna be that long though?
We have to do it all.
Someone gotta be short. Like,
That's okay.
no, like, golly. I'll be done over to 2 in the morning.
You got all weekend, Shami. That's right.
No, I don't.
It's a weekend made for polynomial division. I love those
Only
kinds.
like 3 in the morning.
You're not going to get home till 3 in the morning on Sunday night?
Today, I have the night.
Oh, well, then you still got Saturday and Sunday.
We have a competition. and we're not
Saturday, I would be
gonna do it until 4 o'clock
tired.
tonight.
Then you got Sunday.
I got practice Sunday.
Sound like you got some problems,
Are you
Shami.
gonna come to our competition?
Landon do too. He got
Huh?
Are
practice
you
too.
gonna come to our competition?
And he's
When's your
standing at the
competition?
beach. How long you saying?
We're going to the mountains tomorrow.
Till Sunday.
We're going to the mountains tomorrow.
We're
No,
gonna
no,
come
somebody.
to
annual
No,
mountain
no, Lance
trip.
said he's staying till the morning.
All right. That's the problem, yes. About this. Usually people are because you look at it and it's like, it looks really difficult, but
You know that you can finish.
because you already know the concept. You're just applying the concept to a bigger picture kind of thing.
Right, we're like the same speed.
All right, what goes on the outside? What goes on the inside?
X.
To the 3rd.
No, it's actually, isn't it supposed to go to 4?
No, you start with whatever the biggest exponent is given and then go down from there.
All right.
Plus,
5x squared minus 7x
Oh, I'll do the square root
plus
side.
2.
so this is good because there's no placeholders needed for this one, right?
X to the 3rd. plus
Don't
5.
let dividing by a binomial instead of a trinomial trip you up because sometimes those are even longer than the ones that you have a bigger one that you're dividing by.
It can
All right.
be longer.
What can you multiply x by to get x cubed?
X squared.
X.
So go to the squareds column. Multiply it around. X squared times x is,
X to the 3rd.
okay. X squared times negative 2 is,
Negative 2x squared.
subtract.
And then
Same change, change.
Okay, what about the other two?
What other two?
Negative 7 and 2.
we haven't gotten there yet.
We'll drop them down as we go. We'll get to them. Just like whenever that was 127 and we only looked at the 1 and 2 first, same thing. All right. Oh, I didn't. There we go. 5x squared and 7x squared. Oh, man.
That's
Golly.
positive.
5x squared and 2x squared is
7x.
7x squared. Y'all didn't even catch that.
I did. I caught that.
No, you can't.
Yeah.
All right.
Exactly.
Drop down the next term. Start all over. What do I multiply x by to get 7x squared? 7x. Go to the x column. Multiply around. 7x times x is?
7x.
Negative 14.
Negative 14x. Remember, I'm subtracting. Same, change, change, change.
I hate saying something.
Negative 7x and 14x is?
7x.
Am I done?
No, you have to remember.
Nope. Bring it down. Start all. The nice thing about this is all the repetition in it. What do you multiply x by to get 7x? 7x times x is? Minus. Good job. Subtract.
You right too fast.
I'm sorry, I'll slow down. I thought I was going slow.
I'm good now. I'm with you.
You Gucci?
Yeah, I had to catch it, you know.
Mm-hmm. Same. Change, change, change. 16's my what?
Top.
Remainder, right? The top of my fraction I'm going to add. So I do 16 divided by what?
X minus 2.
What was my time on that one?
Like 3 minutes.
See?
That's because you weren't doing it. Everybody else is not even 3 minutes.
Yeah.
It's gonna take everybody else 30.
I did it ahead of you, so.
All right. Let me.